we talked about basics of hypothesis testing. There we looked at 6 steps for doing any hypothesis test, and we looked at various aspects including alpha, beta. In addition, we also looked at 2 types of error. And very important thing which we learned in that section was that in hypothesis testing, what we do is we take sample, and based on those samples, we try to predict about the population. And this we do with a certain level of confidence. Most of the times, we do with 95% level of confidence, understanding that whatever judgment we make, 5% times that judgment might be wrong. Depending on different situations, you might choose different level of confidence. So this is something which we have learned earlier. Now coming to this topic, which is tests for means, variances and proportions. Here we will be looking at various types of tests which we can do. So earlier we just looked at the basics. Now let's look at the specific type of tests which we will learn here. Broadly, we can classify these tests into 3 categories: 1 sample, 2 samples and more than 2 samples. In 1 sample, we have number of tests. So if you look here on the slide, we have 1 sample Z test, 1 sample T test, 1 sample proportion test and 1 variance test. Here if you look at these 2, the first 2 are related to mean. The second one is related to proportions and the third one is related to the variance or the sigma square. Same thing is for 2 sample test as well. In 2 samples test, we have number of tests which are related to mean, which are 2 sample Z test, 2 sample T test, pair T test. So these are the one which are related to mean or the mu. Then we have 2 proportions test which is related to proportions, and then we have 2 variances which is sigma square. And then when you have more than 2 samples, we have a test called ANOVA. This is related to mean of more than 2 samples. So earlier we talked about a case where we were making perfumes and we wanted to check whether the mean of the perfume in the bottle is 150 or not. Here what we were doing was, we were taking some samples, we were finding out the mean of those samples, and based on that mean, we were predicting about the population or predicting about the machine, whether the machine has changed or not. So what we did there was, we took 1 sample from a machine. That sample could be consisting of 4 pieces, 10 pieces or whatever number it might be. But we were taking samples from 1 machine. And that's the reason this was 1 sample test. So what we did earlier was 1 sample Z test. You do 1 sample T test instead of Z test when either you have less number of samples, less than 30, and also you don't know the population standard deviation. But earlier we knew the population standard deviation as 2 cc. So that's the reason we went for Z test. If we did not know about the population standard deviation and we had less number of pieces in the sample, then we would have gone for T test. In proportion test, we compare proportions. So let's say if you have a data or the fact that in a particular town, there are 10% people who are smokers. And what you do is to verify that or to check that whether the situation is same or the situation has changed, what you do is you randomly pick some people. Let's say you pick 100 persons and you check whether they are smokers or non-smokers. And you find out that 12 people are smokers here. So out of 100, 12 people are smoker. Now has situation changed from 10%? Because the fact we had was that the town has 10% smokers. But in this small sample, we found out that there are 12% smokers. So has smoking habits changed? Probably you cannot say that, because what you are doing is you are picking a sample. In that sample, sometimes you might get 12% smokers. Another 100 people, if you check our survey, you might find that 8% are smokers. So whether there is a significant difference in the smoking habits or not, for that what we do is we do proportions test. And in proportion test, what we are doing here is we are comparing this sample of proportions against the standard or the known proportion. So here we are talking about one proportion test. Similarly, you could do one variance test where you check whether the variance has changed or not. So in the same example of perfume bottles, when we know that there is a variance of 4 cc, and let's say if you picked some samples, 4 pieces or 20 pieces, and you find out the variance of those 4 pieces or 20 pieces, then with that you want to check whether the variance in the population has changed or not. That would be a one variance test. As against one sample test, there are two sample tests. So here what we are doing is, we are not comparing the test statistic against the population. What we are doing is, we are comparing test statistic of one sample against the other sample. The mean of one machine versus the mean volume of other machine, not against a standard value of 150. What we are doing is, we have two machines and we want to check whether the mean of these two machines is same or different. That's where we will be doing two samples, Z test or T test. You do paired T test where you have situation before or after. Let's say if you invent a medicine to reduce the blood pressure, you take 20 people, you find out the blood pressure of those 20 patients and give them the medicine and then check the blood pressure again. So here what you have is before and after condition. There you use paired T test. You use paired T test when you take an exam before the course and the same exam after the course to check how much improvement students have gained. That's a paired T test. In a two proportion test, you have two proportions. So here you take a sample from one town and you take a sample from another town and see that out of 100, how many people are smokers. So here what you are comparing is two towns. So that's the reason this is two proportions test. Similarly, you could do two variances test. Here what you are doing is, you are comparing the variance of two separate populations. In case of perfume, you are checking the variance of one machine versus the variance of other machine, to check whether there is a significant difference in the variance of these two machines or not. When you have more than two populations, then what you do is, to compare the mean, you cannot go for two sample Z test or two sample T test, because in two sample T test or Z test you can compare two populations only. If you have more number of populations, then in that case you go for ANOVA. So let's say if you have 3 machines or 4 machines and you want to check whether the mean volume by these 3 or 4 machines is same or not, there you do ANOVA. In ANOVA, it will tell you that one of the machines, one or more of the machines here has different volume. That's where you go for ANOVA. So this was a quick broad overview of the types of tests which we are covering here. The first test here is one sample Z test, which anyway we have done when we were learning about the basics of hypothesis testing. But now let's go back and learn once again one sample Z test in a little bit more formal way. Let's see that in the next video.